Welcome to World Decoder. Today we uncover a paradox where simple technology challenges the most advanced defense systems in existence. In an era dominated by 5th generation stealth fighters and intelligent interceptors, a strange anomaly is occurring in conflict zones globally. A drone costing no more than a used motorcycle is humiliating the most expensive air defense networks in the world. This is the Shahed 136, a weapon often called the Phantom or the Flying Lawnmower, originating from Iranian engineering facilities. Why does a technology considered primitive by modern standards manage to confuse the most sophisticated electronic brains of our time? Let us decode this mystery together. The first surprise lies in the shocking simplicity of its fundamental design philosophy. Instead of using expensive aerospace materials or complex jet engines, the designers utilized readily available civilian components found everywhere. The heart of this Phantom is the MD-550 engine, a 4-cylinder 2-stroke motor, typically used in agriculture or hobby planes. It does not provide high speed, but it offers two massive advantages. It is incredibly cheap and produces very low heat. Modern heat-seeking missiles hunt for the scorching exhaust of jets, but the Shahed remains nearly invisible to these sensors. With its distinctive lawnmower noise and minimal thermal footprint, this drone becomes an extremely difficult target to successfully lock onto. The second secret is its accidental stealth. The fuselage is not made of military aluminum, but of simple composite materials. Physics dictates that these non-metallic materials absorb radar waves significantly better than metal, drastically reducing its radar cross-section signature. To a radar operator, the reflection area of this dangerous weapon looks no different than a large bird flying by. This is why million-dollar systems like the Patriot or IRIS-T sometimes completely miss these slow-moving threats during active combat. The art of hiding lies in how it moves. The Shahed is programmed to fly at incredibly low altitudes. By flying under 100 meters, it utilizes terrain features like hills and tall buildings to mask its approach effectively. Ground radar waves struggle with clutter from static objects. It is hard to distinguish a drone from a moving truck. Then there is the tactical turtle speed. Modern air defense radars are calibrated to detect high-velocity threats like jets. They have filters to ignore noise from migrating birds or clouds. The Shahed accidentally falls into this ignored velocity category. With a speed of only 180 kilometers per hour, it bypasses the alarm triggers of sophisticated radar algorithms. But the most terrifying weapon of the Shahed is not its warhead, but its sheer quantity and swarm capability. They are rarely launched alone. They are fired in waves of 5 or 10, creating a tactical swarm attack. Every air defense system has a limit on how many targets it can track and engage at a single moment. When a swarm arrives, the defense computers are forced to work at maximum capacity, often letting some threats slip through. Now let us do a simple calculation from World Decoder. A modern interceptor missile costs anywhere from $2 to $5 million. In stark contrast, a single Shahed unit costs only about $20,000 to manufacture and deploy in the field. Even if the defense shoots down 100% of them, the defender still suffers a massive financial loss, mathematically. This is the definition of attrition warfare. The winner is not the one with the best technology, but the cheapest. It becomes a battle of sustainability, draining the opponent's ammunition stockpiles and financial reserves until they can no longer fight. The Shahed 136 has completely shifted modern military thinking, proving that effectiveness does not always require the most advanced microchips. It demonstrates that military secrets sometimes lie in the intelligent combination of civilian components and ruthless, pragmatic, tactical application. A Phantom does not need to be fast or strong. It only needs to be cheap enough to be everywhere. Its purpose is to exhaust the enemy, causing them to run out of both patience and critical defensive resources. Do you want us to decode the nemesis of these Phantoms, or explore Iranian hypersonic technology in our next episode? Subscribe to World Decoder and leave your opinion in the comments below. We want to hear your thoughts on this. Let us look deeper into the engine mechanism. The simplicity of the propeller design is actually a masterclass in aerodynamics. The delta wing configuration provides excellent stability and lift, allowing the drone to loiter in the air for hours. From the Middle East to Eastern Europe, this specific design has been spotted in numerous conflict zones across the globe. The manufacturing process is so streamlined that production can be scaled up rapidly without needing specialized high-tech facilities. While jets require teams of engineers for maintenance, these drones can be prepared for launch by a small crew quickly. Operating at night makes them even deadlier, as visual detection becomes impossible, and defenders must rely solely on struggling radars. It relies on commercial satellite navigation systems. While jam-amble, the sheer volume of attackers makes complete jamming very difficult. Even against electronic warfare, the drone's inertial guidance system can keep it flying towards the target without satellite signals. The 40-kilogram warhead is not massive, but it is sufficient to destroy critical infrastructure, radar stations, or ammunition depots. Precise strikes on infrastructure can paralyze a city's power grid, achieving strategic goals without needing massive heavy bomber aircraft. With a wingspan of roughly 2.5 meters, it is compact enough to be transported in standard trucks. This mobility allows launch units to hide in plain sight, looking like civilian logistics vehicles until the moment of firing. Military analysts studying the wreckage are often baffled by finding components that can be bought online by anyone globally. This accessibility of parts means sanctions and blockades are less effective in stopping the production of these persistent aerial threats. The supply chain is decentralized and obscure, making it nearly impossible for international authorities to completely cut off the flow. Old-school anti-aircraft guns are making a comeback, as they are a cheaper alternative to missiles for countering these drones. We are seeing a return to World War II tactics, with searchlights and machine guns being deployed to save missiles. Systems like the Gepard have proven effective, using bullets instead of missiles, offering a more economically viable defense solution today. A burst of ammunition costs a few $1,000s, balancing the economic equation much better than firing a $1 million rocket. However, hitting a small, moving target with small arms fire is incredibly difficult and poses a danger to civilians below. Newer versions of the drone are reportedly being programmed to perform maneuvers, making them even harder to track and shoot. Recent adaptations include painting the drones black to absorb light, further complicating the job for visual search teams at night. The success of the Shahed has inspired military engineers globally to develop their own versions of loitering munitions and cheap drones. We are witnessing the democratization of air power, where mass quantity and low cost are becoming the new strategic superiority. The next evolution will likely involve artificial intelligence, allowing these swarms to coordinate attacks autonomously and adapt to defenses instantly. In response, defense industries are rushing to develop laser weapons, which offer a cost-effective way to counter cheap drone swarms. A laser shot costs only the price of electricity, potentially restoring the economic balance in favor of the defender again. However, lasers have their own limitations, struggling in rain, fog, or smoke, meaning the cat and mouse game continues. The eternal race between the shield and the spear has entered a new chapter, defined by economics rather than firepower. The Shahed 136 stands as a testament to the power of asymmetry, proving that simple solutions can disrupt complex systems. Military doctrines written over decades are being rewritten in real time as commanders adjust to this low-cost, high-impact aerial threat. For the average person, the sound of a lawnmower engine in the sky has taken on a sinister and terrifying new meaning. The barrier to entry for aerial bombardment has been lowered, raising concerns about non-state actors acquiring similar dangerous capabilities soon. It is not just about the hardware, it is about the knowledge. The blueprint for cheap air superiority is now public. Defenders must now be more mobile and adaptable than ever, knowing that a swarm could appear from anywhere at any time. Constant vigilance is the only defense. The skies are no longer safe just because you have air superiority with jets. It is a modern retelling of David and Goliath, where a small stone can bring down a giant if thrown correctly. As we look to the future, the lessons learned from the Shahed will shape the next generation of warfare technologies. Engineers are already working on what comes next, likely focusing on even cheaper materials and smarter autonomous guidance software systems. To summarize, a simple engine, stealthy composite materials, and swarm tactics create a weapon that defeats billion-dollar defense budgets. This forces us to ask a difficult question. Is high-tech always better, or have we over-engineered our own defense vulnerability? At World Decoder, we are committed to bringing you the objective truth behind these complex military and technological developments. If you found this analysis insightful, please support our channel by hitting the subscribe button and sharing this video. Your support allows us to continue decoding the world's most fascinating mysteries. Check out our other videos on screen now. The sky is vast, and the threats are evolving. Stay curious, stay informed, and never stop questioning the world around you. Thank you for watching World Decoder. We will see you in the next episode with more secrets to unveil. Goodbye.